In this video, I'm going to solve question 8 from paper 1 from Gauteng 2019. The question is on logarithmic function. Okay, so this is the question. It's question 8 on logarithmic function. You can see you are given a log graph and a straight line graph. Okay, so you have 8.1. On 8.1, you have 2 sub questions, and 8.2. On 8.2, you have 3 sub-questions. Okay, the total is 9 marks. Okay, let's get started on the next slide. Okay, let me get the question again. Question 8, this is the question. Okay, question 8, right? 8.1, write down values of x for which 8.1.1 f of x minus g of x is greater than 0. The question is 2 marks. 8.1.2 g of x times the inverse of g of x is less than or equal to 0. The question is 2 marks. Okay, you have 2 sub-questions on 8.1. Okay, you are requested to get the values of x for which f of x minus g of x is greater than 0 and g of x times the inverse of g of x is less than or equal to 0. Write down the values of x for which this is valid. Okay, solution. Let's start with 8.1.1. Okay, for you to get f of x minus g of x greater than 0. Greater than 0 means positive. For you to get a positive answer, f of x must be greater than g of x, right? F of x must be greater than g of x so that you can have greater than 0. So you are going to compare the 2 graphs. You can see when you compare the 2 graphs, f is only above g only on this interval from 0 to 2. From 0 to 2, f is above g, right? So when f is above g, it means f is greater than g, right? When f is above g, it means f is greater than g. And when you have a greater value minus a smaller value, you're going to get positive, an answer which is greater than 0. Okay, so only from 0 to 2, but you are going to exclude 2. You can see at 2, the 2 graphs are equal to each other. When you have the 2 graphs equal to each other, you are going to have the same value minus the same value, and this is going to give you equal to 0. You are not interested in equal to 0. You don't have equal to 0 there. You only have greater than 0. So you are going to exclude 2. You are going to show that with a round bracket. So the answer to this is x element of from 0 to 2, and 0 is also excluded because at 0 the graph of g is not existing at 0 because the graph of g is not touching this vertical asymptote at 0. This is another way to answer this question. You can give your answer like this or like this. Okay, this means x is in between 0 and 2. Okay, you take all the values between 0 and 2, but you exclude 0 and 2 because you don't have an equal sign there, meaning 0 and 2 are excluded. You can see that with a round bracket, meaning 0 and 2 are excluded. Okay, now question 8.1.2, the question is g of x times the inverse of g of x is less than or equal to 0. Okay, g of x is equal to, you are given g of x, right? Log of x base 2. Okay, log of x base 2. This is g of x. You are given it. And you also need the inverse of g of x. This is equal to 2 to the power of x. Okay, if you are struggling on how to get the inverse equation, please check my other videos in which I explained how to get the inverse equation. Okay, for now, you have to know that the inverse of g of x is equal to 2 to the power of x. Okay, now you have to answer this question, right? This is what you are requested to answer. You have to get the x values which are going to satisfy this. Okay, so let's do this. Let me close this. I'm going to have the two graphs, the graph of g and the graph of the inverse of g, on the same Cartesian plane so that you can compare the two. Okay, this is the graph of g and the graph of the inverse of g. I hope by now you know how to draw this. Please check my other videos in which I explained how to draw this. Okay, so these are the two graphs, the graph of g and the graph of the inverse of g. So for you to have this satisfy, you can see you need this times this less than 0. Less than 0 means negative. So either of them must be positive and the other one negative. So that you can have positive times negative, you are going to have negative, or negative times positive, you are going to have negative. So you can see now when you compare the graphs, you have to understand that when you have the graph below the x-axis, it means the graph is negative. You can see this is negative when it is below the x-axis. When it is above the x-axis, the graph is positive, right? When it is above, it is positive, below, negative. At the x-intercept, it is 0. And when you check the graph of the inverse of g, it is everywhere positive, because the graph of the inverse of g is always above the x-axis. So it is positive everywhere. So you need to have one negative and the other one positive, because you know that negative times positive, you are going to get negative, right? So when you compare the two graphs, you can see only from 0 to 1. From 0 to 1, the graph of g is negative, right? From 0 to 1, the graph of g is negative. And from 0 to 1, this graph is positive. It is even positive everywhere. So you need this part. When this is negative, this is positive. Negative times positive, the answer is going to be less than 0. Less than 0 means negative. You also have equal to 0. Can you see you have an equal sign there? Equal to 0. So you need to have either of them equal to 0 or both of them 0, because you know that when you have times 0, you're going to have equal to 0. So the graph of g is equal to 0 at 1. So when this is 0 there, times this one, you're going to get equal to 0. Okay, so 1 is included. You're going to show that with a square bracket. So the answer to this is going to be x element from 0 to 1. And 1 is included. You show that with a square bracket. Or you can write the answer like this. X is in between 0 and 1. Right? 1 is included. This is why I have an equal sign there. Okay? So your answer can be given like this or like this. Okay? And we are done with 8.1. Now let's move on to 8.2. Now 8.2, you have 8.2.1. The question is write down the equation of the inverse of g in the form y is equal to. The question is 2 marks. Okay? 8.2.2, explain how you could use the given sketch to solve the equation. This equation, log of 3 minus x base 2 is equal to x. Okay, we are going to solve that. The question is also 2 marks. 8.2.3, write down the solution to this equation, right? Log of 3 minus x base 2 is equal to x. The question is 1 mark. Okay, solution. We start with 8.2.1. You are requested to get the inverse equation of g, right? You have to get the inverse equation of g in the form y is equal to. Okay, what is g of x equal to? Remember from the question, g of x. This is g of x, log of x base 2. Okay, log of x base 2. You are given g of x there. So now the question is to find the inverse of g in the form y is equal to. You know how to do that. Okay, so let me do that. Before you can get the equation, the inverse equation, you wanna have g of x as y, right? So you change this to y, and then after this, you are going to switch your x and y. Wherever you have y, you are going to have x, and wherever you have x, you are going to have y. Okay, you wanna make y the subject of the formula. Okay, so you can see this is the base. It is written as the base. This is the base, and whatever you have on the other side is your exponent. So you have log this side. Everything that you have on the other side is your exponent. This is your base, and this is your exponent. Okay, as simple as that. Now 8.2.2, the question is explain how you could use the given sketch to solve the equation log of 3 minus x base 2 is equal to x. Okay, let me write this down. Explain how you could use the given sketch to solve the equation. Okay, before that, you can try to rearrange or rewrite this in another way. Maybe it can help you to see clearly what the equation represents. Okay, let's do that. You can tell that this is your base, right? 2 is the base, and whatever you have on the other side is your exponent. Always, this is your exponent. This is the base. It is written as the base. This is the base. So you can write it as the base. And whatever you have on the other side of this expression, the expression having the log, whatever you have on the other side is your exponent. You write it as the exponent. This is equal to what you have there. This is always the case. You have the base, and on the other side you have the exponent. Okay, you can see this is written as the base. Okay, now from this you can see, when you check the equation, you can see that you have 2 to the power of x, and you have 2 to the power of x. This is actually the graph of the inverse of g. Here it is written as in the form of y is equal to. So this is the inverse of g of x, right? So this is this, right? And when you check the graphs, you can see that this is actually the graph of f, the line. Can you see that? Can you see the graphs of f of x is equal to negative x plus 3? This is the graph of f. Negative x plus 3. You have negative x plus 3, right? This is negative x plus 3. So this is the graph of f. So for you to solve this equation, you are going to use the point of intersection, because you have this graph is equal to this graph. Okay, the graph of the inverse of g is equal to the graph of f. So what you are going to do is to use the point of intersection of the inverse of g and the graph of f. Okay, you can even see that if you draw the graphs. Let me show you. So I have the graphs here. This is the graph of the inverse of g, and this is the graph of f. Okay, so the inverse of g and the graph of f, the one given from the question, and this is the graph of the inverse of g. Okay, they intersect at that point. So this is why you have to use the point of intersection to solve this equation, right? Because they intersect at that point. Okay, so you can see. Now 8.2.3, the question is write down the solution to this is equal to this, right? When you rewrote this equation, you find out that it is actually the graph of the inverse of g and the graph of f. So the solution to this will be x is equal to 1. The answer to this is x is equal to 1. Okay, that's how you can answer this question. You can see the two graphs are intersecting at that point, and at that point x is equal to 1. Okay,